Good evening, everyone, and thank you all for joining today. So, we are excited to welcome you all today for the webinar where I'll be talking about matrices for media and gaming. So, so during when I'm providing the webinar, if you have any questions, please feel to drop any of your questions in the chat or in the QA section of the webinar meeting here. Yeah. So. Moving on. So my name is Edwin, and my role in HeadSpin is I'm a custom success engineer, and I am familiar with Python and I'm familiar with automation frameworks like Appium and Selenium. So before I start with the topic, media and gaming topic, I would like to give I'm giving a quick introduction to HeadSpin here. Yeah. So HeadSpin HeadSpin is it's a web-based application that hosts many devices like Android phones, mobiles, TVs, browsers, etc. And these are actually real physical devices which we actually have a physical connection, which we physically connect and integrate to our HeadSpin platform. And then using our platform, you can actually remote access these devices, start interacting with them. And these devices, physical devices, actually can be hosted in different locations. And as these are physical devices, we also have real network carriers. You can actually set it up, and also real network connections like Wi-Fi, and all. You can set that up. Now, for testing and automation API, so it's been actually offers you the ability for to run tests on these devices. So if you have if you have a CI/CD pipeline, you can actually integrate and connect to our devices and start running tests on them. So we actually support various frameworks, and you can integrate your CI/CD pipelines there. So for example, we have Appium frameworks already set up, servers set up in and integrated. So if you have also an Appium script that you have already prepared, or if you like to proceed with an app framework script, you can actually use that to run automation, integrate into HeadSpin and use that for automation. And we also have other framework support, like for example Espresso and many more, which you can actually integrate to our HeadSpin platform and start running tests. So for performance QA and machine learning, so while you're running tests, HeadSpin gives you the ability to capture, record, and store this data. So that is called, we have something called session recording and waterfall session there. So once you run the test, you start recording, you actually have this data where it will capture the device level metrics. All that metrics that you would like to get from the device, you will be able to get that. And along with that, we will be able to capture the video and audio as well. So again, using the data, there will be some analysis that also HeadSpin provides. Like we have ML algorithms that analyze this and provide some suggestions, or like issue cards we'll be able to provide there. Now, insights and actions. So the data we are collecting. So we will be not running only just one test. We will be running multiple tests, and for each cycle releases, you will be continuously running tests over there and trying to analyze the data that you have. So with the large number of data sets, you will be grouping and comparing. So with the changes of version, you'll be able to compare. With the use of this data, you'll be able to comparing this data, and with that, you'll be seeing whether you have like an increase in performance, decrease, whether any changes depending on the version, etc. So this will help you to understand, and if there are any improvements that you want or changes that you need, that you will be able to implement that. Yeah. So in this slide, current slide, over to my over to the right side of the slide, you can see this is the basic HeadSpin UI that you see here, where you can see the remote, uh, the device that's launched here. So you can actually see it is being streamed here. And again, you can, this is a remote accessing to the device, and you will be able to interact with the device here. And based on how you have taken HeadSpin, then you will see a number of devices that are. Now towards the left side, we have something called HeadSpin PP box. So this is our HeadSpin hardware, where we have like a, host or a server, and we have a device that is connected to this host or server there. So this device is again physically connected. This is a physical device, and it's physically connected to this host, and this helps to integrate this to our HeadSpin platform there. And below that, we have something called AV box, AV box setup. So this setup is mostly for like the TV devices, like where, for example, you have Roku and like Tyson TV, etc. And so this setup is used mostly for those devices. And also, this setup is used in case of certain use cases where you would like to check DRM content. You will be testing with the DRM content videos, etc. So there you will be using this. So next, I'll be like going introduction on media and gaming. So here, so as today we are seeing increase in consumption of media and gaming, and especially uh, you are able to you are accessing this through a portable device like mobile devices. You have handheld devices, and you're also seeing contents over your TV and etc., where you will be able to access through an OTT platform. And uh, as we see a large performance boost, that is, yeah, you are seeing like improvement hardware. So like CPU and GPU and display, that you get a higher performance GPU, CPU, and you are get a higher quality display. Along with that, that you are getting all these packed into a smaller devices like mobiles and all. Additionally to that, we have like a getting a more reliable internet, that is like you get 4G, 5G, Wi-Fi 6, etc., where you get a so where you get a high speed and lower latency network. Now all these actually improvements or performance actually give you a richer experience, where in these devices you can actually watch 4K videos, do a live stream. So from like a region, from one region to the end of the other world, you can actually see a live stream there. Also, you can actually do a live call where with very very minimal or like zero latency, you will be able to do a call, and you will be seeing interacting there live. And so also these high performance hardwares which you see in mobiles, so this actually enable you to get a higher quality gaming experiences, where you see high performance and higher quality content or experience there, and with low latency, where due to higher speeds of internet you get lower latencies, and these where this can be accessed anywhere. This is portable with these mobile devices, and you can interact or play with other users all around the world. So now, as this all these are introduced here, so we would this is also required for us to test like what is the experience that a user gets. So as we are on our HeadSpin platform, we are setting up real devices. You will be testing you can test on these real devices, and this will provide you a real data from it, whereas for example like you're testing on different types of devices there, and then again different networks, different regions that you're testing. So this will help you to get all those data and have a comparison, understand the experience that a user gets. So in this slide, I, as you can see here, after these are certain matrices that it's been captured. Once it captures, this is how it's been represents this as a time series graph. So you'll be able to uh, visually see and analyze this and check depending on each time frame what is the metrics values that you're seeing there. So moving on to media matrices. So we have here I'll be just giving a few matrices that you can utilize for your media testing. So we have something called MOS, blockiness, blurriness, FPS, janky frames, downsampling, and then we capture network calls and audio. So MOS is like where we have a trained ML algorithm that actually analyzes this the video that it the capture, and it gives you analysis where how a human perceives or a user perceives the video. So it'll give you the rating based on how a user sees a video. And like blockiness, it's like the measure of intensity block. So it's like if you're seeing a visual distortion in the video within the block or a pixel. So especially you will be especially seeing this on a faster moving scenarios or a low quality streams there. So mostly this will be noticed by in a like a compressed video, like a compressed video that are like being saved. So this helps you to have understand the quality, how clear or distorted a video is when you're watching, especially over through a network. Next is blurriness. So blurriness, it's like measuring of blocks due to compression artifacts. So this actually helps you to look how a video when a video is out of focus or softness, uh, lacking any sharpness. So this is actually you can utilize this on a like a for a live stream calls, or like you can use this on a when you do a live stream over there or during a call, etc. So this happens maybe due to a low video quality resolution, or when a compression happens over the video, and when it gets encoded back. Then we have frames. So frames, it's like we are capturing device level frames where so during a video stream, what's the frames observed at that time, we'll be able to understand that. Next is junky frames. So this is like where any you'll be able to identify where there are any frame drops happening. So like for example, like you're doing any streaming happen, any streams are happening, or like you're doing a live video call. So if you see like if the frames are dropping and you see like image by image, then that will be giving you a bad experience. So there, so this matrix will help you to understand the frame drops there. Yeah, next is downsampling. So this is like measuring the downsample of video in video frames. So it's like you'll be able to understand visual details is how much visual details is lost when a video is like video frames is shrunk, like if it's compressed, like, or if it's blown out, depending like if you are getting a low quality, how it is experienced on a higher quality screen, or like when a high quality video comes in, how it is, what is the experience that you're seeing on a lower side. So it's like a resolution scaling there. Then we have network calls, like so during the testing phase where you do this capturing, you actually able to log the network logs that is being sent during your testing by your application and the device that time. And this will help you to do some analysis where you see in latency or such. And then we also have audio. We also capture audio, and there you will be able to understand what is the loudness and quality being provided there. Yeah. So moving to the next slide. So here I've given a sample waterfall session that we have captured here. So here in this example, we have something where our ML model actually analyzes the waterfall session and it provides an issue card. So you have like a loading animation. So what this helps to understand is like throughout your testing or like through your automation, how many loading animations have happened, at what time interactions on the application where the loading is happening. So if like for example, you're you're picking up a video like your phone and like trying to start watching a video there. Now maybe due to latency or like poor quality internet or change in internet speeds, you may experience like a video buffer there. So buffering, like you will see a loading animation there. So this will help you also to identify if the loading animation is taking like a more than a few seconds, maybe two, or like there the person who's trying to watch it may be frustrated or like will not be less interested on that, and they will be moving on to the next video or next application there. So this will help you to understand where you will be testing out uh, this especially on different networks, so you'll be able to understand what is the like buffer time. Is it buffering a lot when you're doing loading different content, or like in a different region, what is the effect happening? So along with that, we have like we'll be able to identify other metrics as blockiness, blurriness. So again, if you have like a fluctuating internet or like different internet speeds, you will also maybe experiencing these blockings, blurriness, which you can also analyze over here. At the same time, you may see like janky frames. So there, if you see that, uh, they will be able to did any frame video drops. So that will help you to actually identify whether any frame drops are happening. So that if at that time, if any drops are happening, so the user might get a poor experience of how when they're watching this content there. So next, I'll be going on to gaming and media, gaming matrices. So here there are few matrices I will like show, that is like FPS, uh, frame render time, CPU memory, battery drain, network calls, and page load. So while you're testing your game, so you would like to also understand your frame rate. So frame rate is something crucial while your game applications are running. So if you have a very low frame rates, the user might get a bad experience where your application takes time to load, and or it show represents that it's taking each frame by frame it will be displaying, so that will be a bad experience for the user. So this will help you to understand depending on each throughout this session and scenario, each when a game tries to load on each part of the page, what is the frames will be. Now frame render time, so it is like a measuring of frame render by milliseconds. So there you will be able to understand like how much time each frame is getting rendered. So this will also help you to understand what, depending on each frame or each scenario that the game application is outputting, you'll be able to understand that. Now we have also other like memory, CPU, battery. So there, so again, memory and CPU is also a crucial thing when, especially for a gaming application, which have like a high uh, graphics content available. So this will help you to actually identify whether how much CPU, or like how much memory it is being utilized, whether there are enough resources being used when a game is loaded, or when a part of a game is loading, or a certain page is loading there. Then we have battery drain. So this again, during our time of application being loaded and loading into the content, and the user being playing, what is the overall percentage it is being used there. So this will help you to identify how much battery drain is happening, and according to that, if you want, you can optimize that. Then we have network calls. Again, like when your application, or if it's taking time, network calls also is a factor. Where if you have a slow internet, your network calls will take time to get a response, send and get a response back, and which again influences how your application is loading. Then we have page load. So this is actually a visual measurement where it measures the visual page transition, and with this you will be able to actually measure certain, like how much time, uh, help you to understand the page load times of your applications. For example, how much time your application launch take times to launch, or like how much time uh, your application gets switched from a login screen to the actual home page and into the game. So moving on to the next slide. So here is a sample report that we have. So while testing, so this is the report that we get, and here in this example, we have our ML algorithm analyzing the frame render time. So throughout the session, we can see there are different frame render times happening here. So each part that you may experience like a different frames. So this will also help you to understand, is their application utilizing the the maximum device frame render frame, or is it using very less there. At the same time, like with the respect to frames, you may also, as you can see the what is the CPU usage and what is the memory that is being utilized there, and the battery overall battery usage that's happening. So depending on the model and all, you may see different experience of your application loading there. So CPU, is it utilizing very high, is it very low? Based on that, you may get a different experiences there. Also, like battery drain. So when your application loads, depending on your is it an optimized application, or is it a high perform has a high graphics application, you may see like a level of battery drain that is happening. So again, when you analyze this, you'll be able to, like, it'll help you to understand, like, when your application launches, how much it's certain scenario of your application, game application loading, how much percentage it is draining, and how much will be there available. So it'll be help you to understand, like, when a user actually opens a device and tries to play it, how much time that user will be able to experience the gaming there. And so if the battery drain is high, then you may get a lower uh, play time there. If it's a high battery, like a low battery drain happening, then you get a longer time duration for the users to play on the games there. Yeah. So that is all. So yeah, please can add them either in the chat on the QA section of the webinar. Okay, so the first question is, do you have any baseline speed setup for network speeds? So answer to that is like, yeah, we use the most popular ISP in our data centers, which has the highest possible speeds available in that region. So again, mobile data are subjected to the speeds available in that area. So another question is like, for performance based, do we you will add extra hardware to the device, or how it works? So the answer to that is like, we actually don't add anything any alternatives to the devices or any hardware there, uh, like how you have a device, right? So we actually get those devices as it is. We don't do any routing or jailbreaking there. So we actually get the data. So when you're doing testing and all, we actually get the data that is that is being generated by from the devices, and then we actually do a visual representation of that. So another question is, the network CPU will show only the application consumption CPU usage. So Headspin, we in Headspin we so all our logs are like device level logs, except for our desktop browsers, which are application specific. Um, so there, like, so there, what we are saying, like, we are trying to understand the real situation where, like, when your application runs on a particular day, so we have multiple devices, different models, different hardwares. So what is the user experience, a user what is how a user experiences when the application that is launched on the device. So what is the behavior, are they getting the experience they are when they are utilizing the application on the device. So that's how it is. So another question is, how can Headspin help optimize media quality across across devices and network? So here, as Headspin, in Headspin, we are actually testing on real devices, right? So there, with the matrices that we have, and we have also like ML driven algorithms that analyzes this data that we have, like video audio quality, and then network logs that we capture to understand the network overall network performance there, and also the performance with based on this we can understand the performance there. So this will enable teams to actually uh, drill down, as we have like our time series where you can actually drill down onto this different matrices, see the behavior or the values that you see here, and then if there are any fixes based on that scenario or the logs that we get, you can actually analyze this, and then it'll help you to actually fix certain, if there are any issues or improvements that is needed, you can actually understand and apply them there based on the regions or the devices that you are testing on. So here's another question, like, can you share the standard data regarding network speed? So yeah, we mostly use gigabit line for our Wi-Fi network and Ethernet networks connected to the devices that we have here. So yeah, another question we have is like, why is it important to test on multiple devices and OS versions? So there, like, as today's world, like for Android and iOS, like we are getting like, or like TV devices and the browsers that are running on different hardwares. So they're having like different hardwares there. It's difference in variance, like we have screen resolution, difference in screen resolution, hardware capabilities. So different hardwares have different capabilities there, and then OS level version. So the improvements that are coming up on different OS versions there. So this will help you to, when you're testing on different devices, this will help you to understand the experience or the behavior that you're seeing for your application, for a user when they are loading your application on the models that the user is handling. So this will help you to understand whether you have like a good quality experience of video when they are referring to, or like a good higher better experience when you're doing a gaming, etc. So again, like, yeah, testing on multiple devices help you to understand the overall performance, or like experience that a user has, depending on the hardware. So another question, this is for profiling or loading emulation is possible with this. Uh, you can actually use yeah. So you can actually use tools like JMeter or load runnings to induce loads on your services, and then use HeadSpin to measure these metrics there. So by utilizing this at the same time, you can actually run tests on your devices. So when you see a load, then you will also be able to capture the real like live real data from these devices during the testing, and then using those data comparison, like how much load you have put, depending on the real data, you'll be able to compare, and which will help you to understand what is the behavior. So there's another question like media metrics. It's default on a waterfall session. So media is turned off by default, but like based on the customer use case, if they wanted to test media, then we actually enable them for as per the requirement. So this can be enabled. Yeah, I'll be waiting more. Okay, now I'll be waiting for some more time. Like if there are any more questions, yeah, please do add. So here's a question like if you want to try it for any use cases, any single user license available. So yes, we have different plans like cloud testing, light, and so like and go, which you can use depending on what you want. You can actually uh, subscribe to whichever license, the required license there. Yeah. So we have like a question like how does it behave with other encryptions on the devices? For example, like laptop having encryptions, how does it affect? So we mostly don't test on laptops. So our major testing is mostly focused on mobile devices and OTT devices like Roku's and Tyson, etc. So another question is like, what is the impact of janky frames on experience in media applications? So janky frames, like it's like frames that freeze or like skip or drop. So this helps you to understand whether the playback is smooth. You're getting a playback, smooth playback, especially in a like fast pacing content as well. And like for gaming, if you're losing if you're getting janky frames, then you are getting a bad experience, as well as on your video content. Like if you're losing like seeing a drop in frames, or is the frames a script, then you will see a better the user who was watching the content will experience a better content. Any more questions? Okay. Yeah. So thank you all for joining us in today's topic, like performance unplugged for advanced metrics for media and gaming. So we hope you find this scenario session useful and valuable. Then, yeah. Thank you all. Yeah.